We have to find the domain of the given function. So here we can see two issues with the logarithm in the numerator. So we know that there are going to be some restrictions, and also we see radical in the denominator. So there are also going to be some restrictions. And we're going to start with numerator. So we know that this stuff inside of logarithm should be strictly greater than 0. So make inequality that x squared minus 100 strictly greater than 0. And we're going to solve a corresponding equation at first. So that's going to be x squared minus 100 equals 0. Therefore, x squared equals 100 and x equals positive or negative 10. So we put those numbers on number line. That's negative 10 and 10. And we know that those values will not satisfy the solution, because if we substitute negative 10 or 10 in our logarithm, we get undefined answer. So we put open circles. And now we're going to check each interval. So we test the numbers from each interval. And we're going to use x equals negative 100. So if we substitute, we get that quantity inside of logarithm is positive. That means that all numbers which are less than negative 10 will satisfy our solution, our logarithm. Then we check x equals 0, and if we substitute x equals 0, we get that inside of logarithm is a negative number, so it will not satisfy our logarithm. And the last one is going to be x equals 100, and we also get positive numbers, so all numbers which are greater than 10 work. And now we're gonna look at the denominator. So normally we would say that this stuff underneath the radical should be greater or equal 0, but now since it's the denominator of the fraction, we can let it be equal 0. So it's just gonna be x minus 8 strictly greater than 0, therefore x is greater than 8. So put this on our number line. And now we're going to look at regions that overlap, and in this case it's going to be a region that greater than 10, therefore our domain is going to be 10 using parentheses from 10 up to positive infinity.